Hello everyone. So in last video we have discussed about how to build a Kubeflow pipeline, and in today's video mainly we'll talk about how to pass CSV file or you say data frame between different Kubeflow component. Because in machine learning world most of the time we deal with the data frames and we generate CSVs. So our requirement is we have different component and then how to pass these CSVs or data frame as a parameter to different component so that one component run after the other. Okay, so these all things we are going to discuss basically. So these are the broad topics we are discussing. So basically we'll start with creating some functions which are required to train the basic iris classifier. Then we'll convert those functions to Kubeflow components. So basically till here you have already seen in last video. Okay, so we'll not invest much time here. We will directly jump to understand how to pass CSVs between components because that is important. Okay, and then of course when we once we pass the component, we'll initialize the pipeline and we will run and we'll see the live demo basically. Okay, and then we'll try to understand how these CSVs are converted to artifacts and stored as the output or input file based on like your inputting or outputting. Okay, so let's start with those things. So guys, these are the anyway same steps, and this is the pipeline we are going to build. Let me little bit zoom out. Okay, so this is the pipeline we are going to discuss. Basically, so we'll prepare the data. We'll start with train test split. We'll train basic classifier. We'll predict on test data, and then we'll get the matrix. Okay, so let me zoom it back so that's visible to you as well. Okay. So here, the very first thing basically, guys, you need to, so guys, I'm assuming, so here this thing I'm explaining in my Windows laptop. So if you have Windows, then of course, you can also run all these steps together with me. But if you have any other laptop, then also most of the steps should run without any problem. You just need to have Kubeflow installed in your local system. But if your Kubeflow is installed in any of the server, then also it's fine. Okay, so I will just tell you like where you need to change in upcoming components. Okay, so no need to worry. So the very first thing, basically, you need to import certain libraries. So for example, import Kubeflow pipeline, KFP, and you need to import the components by which we'll be building the components. And from component, you can also import certain methods. For example, create component from function and input path or output path. Okay, so these will be using to communicate with CSVs generated and output as CSV. So we'll see how to use them. Okay, and then request for and then DSL. So to create the pipelines, basically this is the domain specific language. And then here, guys, one more thing, I'm using Kubeflow version 1.8.18. So you can also install at least 1.8 version, okay? Because in previous version of 1.5, there are some, or 1.3 you say, okay? So there are some incompatibilities with the current version. So, I mean, so you can use the same version, so all the steps will run smoothly. So no problem. Then the very first function what I'm using, prepare data. So here you see, so guys, in today's talk, the important thing is to understand the parameters. Okay, so that's where we'll talk more. So the first thing basically here, what I'm doing, I'm defining a output underscore CSV parameter, and I'm defining output path as a function. Okay, so this is the way you need to, if you have done some pre-processing here and you generated some data frame, or I would say CSV, and you want to pass to the next function or component. Okay, so for that, you need to store that as a serialized string. So basically here I'm talking about CSV, but there are many other file formats also supported, for example, pickle. So the all those formats which are easily serialized to string. Okay, so if you have any specific requirement for any specific file type, then of course you can ask in the comment, I will discuss. But here let's focus on data frame or CSV because those are the most widely used one. Okay, so here if you so if any CSV, if you want to use in the next component, so in this component you want to output it, so for that you need to define using output path. Okay, and here I'm taking a CSV URL as an input because in that CSV URL my input file is loaded, I mean stored. So these two parameters I have defined, and here none means this function is not returning anything, but internally it is assigning this CSV file to the output path. Okay, so that in next component we can accept it. So I will show you like how to accept this basically. That is important. Okay, and remaining thing here, you all know, you all are a programmer, so you know like what I'm doing here. Basically, I'm accepting a CSV URL, and here I'm from that URL I'm reading the CSV into the data frame, and here these are the libraries I'll be using. And one more thing, guys, I have already explained in my previous videos. So basically, these components. So this is a function, and later I'm going to convert it to the component, Kubeflow component. So every component will be running in a separate pod inside containerized environment. So that for every pod, you need to define what all libraries are needed. Okay, so that's where I'm defining it here. Then I'm reading CSV URL in the data frame. So this is our data frame. So here I'm not writing all other steps which are required to prepare the data. So you can write those, because here scope is not to explain you machine learning, but scope is to understand like how to pass CSV files between component. Okay, so let's jump to that section. And here, if you want to see how your DF is coming, so df.head you can print. And next important thing is this one, basically, guys. So here with open, so basically I'm opening a file with the output underscore CSV. So guys, remember you need to define this exactly as this, because this variable will hold the binary serialized string of those CSV. And as a W means write back as F. So this is just a local object. So df.csv is in that F, and index I'm making it false. Okay, we don't need that index. So that's where like df.csv. So this F and indirectly this output underscore CSV will hold the binary serialized string of that CSV. And now coming to next section. Okay, so let's execute this thing. So let me first restart and clear our output. Okay, and we can write it from the beginning. Just a minute, it should restart. Okay. Yeah, so now you see here, so it is restarted. So now let me run this. So it's a 1.8.18. I already explained. Let me execute this. So basically, I'm just compiling. I'm not executing. So once I call, it will execute. Okay. So next function is like train test split. So here, guys, I'm just explaining a Python function, but in a different way. In a Python function, you don't pass the parameter like this. But because I'm going to use them as a component. So that's where there is a slight difference here. So here you see like I generated the data frame and converted that to CSV and store that in output CSV. Now how to take that input in the next function, basically. So here you see like we have input path. Okay. So using this input path, I will accept this output CSV in this input iris CSV. Okay. So that's how you can accept. And then again, I'm just splitting into train test. So I'll be outputting two CSVs here. So you can output more than one file, basically. And of course, you can take input also more than one. You can define one more input path here using comma separated. Okay. And then none, because I'm not returning anything, but internally I'm storing in this one. Okay. So in next video, I'll also talk about like name tuple. Okay. So where I'll be returning multiple objects or data types, for example, list, dictionaries. Okay, so that's where we'll talk about how to deal with this none. Okay, so instead of this none, we have to have some return type. So we'll talk that. But today, let's focus on CSV. So now here we have again, as I said, like this will be used as a separate pod. So we need all the dependencies, libraries here. So let's import those things. And then again with open. So here I'm inputting this CSV path. Okay, so here input iris CSV is hold the object of this one, because that I'm going to pass as a component here. So here in input iris CSV as F, you can read simply. So now in this DF, you will have same DF as you generated here in previous component. Okay. And now later stuff is fine. You simply do the train test split. You define the test size, random state, stratify. So here you define the target variable, and then you will have a train test split with the 20% ratio. 80% train data and 20% test data. Okay. So here I'm printing. So this will be printed as a log. And then again, open CSV, again, I need to output these two CSVs like a train DF and test DF. So here, guys, so one more thing, guys. So as of now, as of today, Kubeflow doesn't support directly passing the data frame. So no worries, you can convert the data frame to CSV with the easy one-line step, and then you can pass the CSV. So your work is done. Okay, so no need to worry. So now here using train df dot to CSV, again in train CSV, I'm assigning to train data set, and test underscore df, I'm converting to CSV, and test underscore CSV, I'm assigning test data frame. Okay, so now this is done. And next, I'm just creating a basic classifier. Here I need a train CSV, because in train data I will be training the basic classifier. And then again here, guys, instead of CSV, I'm returning a pickle file. So you also learn how to return the pickle file, basically model, basically. So it's the same way. You just define the output path, because ultimately everything will be serialized and converted to a string. Okay, same way. And here I'm accepting target column as str. So whatever target column is here, so this class, so I'll be sending as a pipeline parameter, which I'm going to explain later once I start building the pipeline. So here, just now understand the functions, basically. Okay, so here, same way, same thing. Train CSV, you read the train CSV. We already learned how to do this, and this is normal ML word. Basically, I'm just doing the uh, sorry, what we are doing here, x, yeah. So here x data, all the dependent variable, and here, sorry, here all the independent variable, and here this is the target or dependent variable. Okay, so x and y columns. Okay, and based on x and y column, we are training logistic regression. Here you pass x train, y train, and then here again, so this will generate a pickle file. So this classifier, and then here I'm storing as a train underscore model. Okay, right back as f, and then again pickle dot, using pickle dot dump, we can dump this classifier into f, and f indirectly object of this train model. So train model will be returned as the output path. Okay, so now come to next function. So here basically we are learning how to pass a parameter in function by function. Okay, one after another. So they will run in a sequence, like whatever dependency is there, based on the dependency they will run. So here now predict on test data. So what this needs basically, it needs a model. So that's where we are passing as the input path, that model. And then we are predicting on test data. So we need the test CSV. So using input path, we are inputting test CSV, and then it will output some predicted values, predicted class. Okay, so that will also convert into CSV and return as the output path. And here we need the target column also, okay, to compare. And now here, again, same way we can read the CSV, and then we can read the model, trained model, same way, right? So, and then ultimately we can do this. We can again split this test data in X test and Y test. In X test, we'll do simply the prediction. So, so here we got this model, and then logistic regression model dot predict, normal predict class, and then we pass the X test, and here we'll have the predicted classes. Okay, and then again convert that to data frame and simply return the data frame in terms of CSV. Okay, convert the data frame to CSV. Then we are returning ypred underscore CSV. See here, you see. Okay, so we got the predict on test data as well. And now if you want to output the metrics as well, here what we need basically, we need a model, we need a test CSV, we need a predicted classes, so that we can compare this predicted classes with the actual target class, because in historical data we already have the target class available. Okay, so we need all these things, and we need the target column, and based on that we of course import all the dependencies here, and then read those files, read the model, I mean load the model, and read this predicted class, and then convert to numpy, because we need in terms of numpy format. And then here we are generating y test, because we need the y test, basically actual classes. And then using accuracy score, just pass the y test and ypred, and it will just do internally comparison and then generate the accuracy. And then you can also generate the precision score based on whatever average criteria you are giving, and the recall score also you can print. Okay, you can get basically, and then you can get the classification report. So this is all ML word. Okay, so this you all know. So our target is just to understand how to utilize those parameters within component to component. Okay, and then we are printing here. So this is fine, right? And now the next thing is like how, so we are done with the functions basically. Okay, now our functions are done. So let me execute till here. So since here we ran, okay, this we ran. So let me run this. Okay, so this is fine. Now understand this. So here we are creating a Kubeflow components. So basically how you can create using kfp.component.create component from function. So you can also ignore this part, because we have directly imported this thing here. If you see here, come here, where it is. Yeah, we directly imported this. So this is available, but yeah, this is all Python words you all know basically. Okay, so now here I'm passing a function as a prepared data. So because for this function we are creating a component, and then what is the base image, like base environment. So we are needing a Python 3.7. So in your case, whatever base environment you need, you can pass that environment here. Okay, and then what else packages to install? So you can define with the version. So it will be good. Otherwise, it will try to download the latest one. Okay, so this you can define, and similarly So here, guys, here till now we are defining the raw component. We are not passing the we are not connecting each component with other. Basically, what we learned till now, it is generating some CSV, and this will consume that CSV. So basically, this is the generator, producer, and this is the consumer, right? So till now we are defining component individually, but when we start creating the pipeline, pipeline is nothing but stacking the components, right? So that's where we'll define the dependency. Okay, so let's learn step by step. So here we are defining the components. So this is also the same way basically. Okay, we just need to define the function. Okay, and then here this also, this all 4 or 5% normally functions we defined. Okay, so there is nothing extra here. So let me run this. Okay, so now here, this is important, guys. Here, so here basically I'm defining the pipeline. So let's define the pipeline name and then description, and then here iris classifier pipeline. So here I'm accepting two argument as a pipeline argument. One is target column and one is CSV URL. Okay, so that will give when we call this pipeline in the next chunk. Okay, next block of code. And here, guys, I commented this because in my previous video where I explained the basic pipeline building, so that's where we have created the volume and we stored generated output artifacts in temporary volume. But here we are not using a volume. We are just whatever is being generated, we are passing to the next component. Okay, so that is being stored as an artifact within the Kubeflow. So that's what we are learning here. So forget about these things for now. So here, first component we are having prepare data. Okay, so create step prepare data. So here, what it accepts CSV URL, the very first one, right? First function prepare data. It requires CSV URL. From that, it will read the CSV. So it could be your any bucket, S3 bucket, it could be a GCP bucket, I mean Google bucket or whatever. You just whatever, if you are using any bucket, guys, so here you need to define how you want to read this basically from that bucket. Okay, I'm using simple CSV. I'm just writing pd.read CSV. So that's normal programming word, right? That's you all understand, fine. Okay, so this is the first component. Now after this dependency will start. So basically what is happening, this next step is expecting output as a CSV from this first step. So what you can do, so here this I am writing prepare data task as a first step. Okay, and dot outputs. So guys, remember this is S outputs, not output. Okay, so many times we do mistake. I did this mistake, that's where I'm just sharing my experience. Okay, so if you do output, then it will return error. So dot outputs, and whatever output you are returning there, output underscore CSV. So this basically this, and let me show you here, this name should be same, otherwise it will give you error. Okay, so make sure this is same as that one. Okay, so that's where whatever you define that function level, you should pass that. And now, guys, now we have established a dependency. Now this task will run only once this task is executed successfully, because this task is expecting a parameter which is generated on this step. Okay, so this way you can create a dependency. Now in second step, what this is like a training basic classifier. So training basic classifier will what it requires basically train CSV, which is being generated here. Okay, and a target column. So target column it will take from the pipeline parameter. Okay, so now this step is dependent on this step. Now let's understand this step. Create a step predict on test data. Okay, this one. So this is predicting basically. So for predicting, it requires trained model. So trained model it is getting from this step, and then trained and outputs like test CSV it is getting from this step. So trend test display. So basically this step is dependent on these two steps. Okay, so once these two steps are ran successfully, then only this will start executing. Okay, and then this target column we are accepting as a pipeline parameter, and then this create step get matrix basically. So here this accept target trained model. So this is coming from this step, and then test CSV will come from train test split, and then ypred. So predict. So this will come from predict on test data from this step, and then target column from pipeline parameter. This is also fine. So this way we have created a dependent Kubeflow components. Okay, and now we have so these are the steps basically, because if you run the same pipeline multiple times, then it fetches the output from the cache. So but here we are experimenting, so we want to see the output every time we run. So that's where you can define cache as a like 0 days. Okay, so process 0D. Okay, so that's where you can define the cache for each steps individually, basically. Okay, and this is how we have defined our complete pipeline. And now next thing is like we need to call this pipeline. I mean, we need to compile this pipeline and create a run. So how you can do? So for that, we need to create a compiler, so kfp.compiler.compile, and here you can pass the pipeline function as a parameter, and then you can pass the YAML file. So this compiled pipeline will be converted to YAML, and as I have already explained in my previous basic Kubeflow pipeline building, you can directly upload this YAML file and execute this. Okay, so in future purposes, you can utilize this. So let me execute this. Okay, and let me execute this as well. And guys, here, so here I'm creating a Kubeflow client object. Okay, so here I'm running this locally, so this will work. But if you are using any hosted server, so what you can do, you can use the session cookie to authenticate yourself and use the host URL, whatever host URL you are using, and you need to pass the Kubeflow namespace. So here, if you go and inside pipeline at the very top, just a minute. Okay, so here, because it is installed locally, there is only one namespace. Okay, so the by default it is Kubeflow. But in your if it is installed in your server, so here at the very top you will see like, because the Kubeflow is multi-tenant. Okay, so you will see like multiple namespaces created. So whatever namespace you are working, you need to pass that namespace here. Okay, and then after initializing those three parameters, you can authenticate the Kubeflow client by passing these three parameters. Okay, so this is a thing you need to do if you are working at server level. Okay, but for local, it will work like this. And then here, now you remember your pipeline is accepting these two parameters. You need to define these two parameters before calling the pipeline. So here, what you can do, basically, you can define target column and your CSV URL. So basically here, because we are with the help of code, we are going to create an experiment and run on top of pipeline. So that's where we need to pass these two parameters out of code. But here, if you are using this YAML generated, okay, then if you are uploading this YAML as a pipeline, then there it will ask you to provide these two parameters. So as an environment variable, you can pass these two parameters. Okay. So if time permits, I will show you quickly. But in last video, I have already shown. So okay, so we can go there and we can watch there. I will just give the link of those videos. Okay, so that's fine. And here again, I'm just importing in the date time so that every time I'm running this, it generates unique pipeline. So let me run this. Okay. And then till here this is fine. Then pipeline function, so whatever pipeline function we have created above, and then experiment name, so I'm just generating unique experiment name so that every time I recall this unique experiment name is generated, so I'm appending with the time, this time. Okay, and then run name same way, and then namespace Kubeflow. Guys, keep make sure you are passing the correct namespace. Okay, and then argument as a JSON. So here, whatever we have defined these two arguments here, and now the compilation, and then after compiling, you can run the pipeline using this. Okay, create run from pipeline function. You need to pass pipeline function. You have defined here. This is the pipeline function. Experiment name you have defined here. Okay, and then run name you have defined above, and arguments. Okay, the moment you run this, it will create a new experiment and new run. So if you go here, okay, like this. So here it is giving a problem because my Kubeflow is running in separate port, that is 8081. Okay, if I correct the port, sorry, 8080. If I correct the port, it will run. Okay, so now it has started running. Okay, so now let it run. So meanwhile, what I can also show you. Okay, so here if you come, so it will run. I will come back to here. But if you go to pipeline, okay, here, so here it is showing upload pipeline section. Okay, so that's where whatever YAML file you have generated. So here you use okay, here. So it will be stored here locally. So from where you have opened Jupyter Notebook, if you go this pipeline.yaml, so 3 minutes ago we have generated. Okay, so you can download this, you can upload that, and you can run simply. Okay, so but let me show this, the current one. So under all run section, this current run will come, and here you see like prepare data. If you go to logs, so whatever output you have printed, it will show those output. I just printed df.head, so pipeline it is showing top 5 lines. But if you come to input and output, okay, so here you see as an input parameter, we have passed this URL. So that's where under input parameter it is showing this. Okay, and other than that, we didn't have any other artifacts, so it's empty. And in output parameter, we didn't have any output parameter, but we have output file. Okay, so all the file related thing will come as output artifact. Any other parameter will come as output parameter. Okay, so as an output CSV, we are generating this CSV file. So if you go here, okay, so it will download the CSV file. Okay, and then you can also see the logs here. Okay, now in train test split, what we are generating, we don't have any input parameter. We have prepared data output, so we are generating output CSV. Okay, and output CSV, and then we have train test CSV. So as a train CSV, this is there, you can download using this, and as a train CSV, we have this. Okay, and any other log will be visible here. So now it is training basic classifier. It will take some few seconds. It will get trained. So now you see we have training basic classifier. If this got trained, and in logs you can see, okay, so large degree. So this whatever print statements you have given inside the component or function, those will be visible here. Okay, but all the artifacts will be visible here. So as the output of training basic classifier, what we have written, a trained model, right? So trained model is getting returned as a pickle file. If you go here, then it will ask you, you can download this, okay, pickle file. I'm canceling, I don't need that. Okay, and one more thing guys here. So now you see here, so prepared data don't have any dependency. It ran a standalone, but train test split is dependent on prepared data. So that's why it started executing after that, because whatever output this is generating, it is consuming. And then whatever output this train test split is generating, basically train CSV and test CSV, this is being consumed by these three components. Okay, so this training basic classifier is trained on train data. So that is coming from this one. And then predict on test data. So predict on test data, basically it requires test CSV, which is coming from here, and it is requiring the trained model, which is coming from here. So that's where we are passing the parameter as a CSV file or pickle file, that is a model, okay, to next component. So here in this one. And now here you see in our input output section, all the artifacts recorded here. So now you see here ypred as output. So it is predicting different classes, right? And then similarly, if you go to get matrix, so here basically what it is generating, the input parameter is target column as a class, and then train test split test CSV basically. So basically here it is telling, okay, which component is coming from. Trained model is coming from this component. Okay, and ypred is coming from this component. So all the artifacts you can see here, and we don't have any output parameters. So that we'll talk about in next video as a named couple or any other normal data types. Okay, and now if you go here, so all the print statements will be visible here. Okay, so this is how you can like pass the CSVs or a data frame converted to CSVs between Kubeflow components. So I think that's all for today's video. Let's not make it too lengthy. So I hope you got all the points, but no worries. If you have any doubt at any component, just comment me in the comment section, and I will try to reply as soon as possible. Okay, so that's all. Thank you very much for watching. And if you're loving the content, so please don't forget to subscribe this and hit the bell icon so that you get notified for the next video. And if possible, please share in ML communities within your colleagues or anybody learning ML. That's how you can help me, and that is very much needed. Thank you.